Hi, I'm from Singapore Polytechnic, here today to present you a question on chemical reaction engineering final year paper 2007/2008, question 17. Here's the question. An experiment was conducted to investigate the effects of temperature on the reaction rate constant. The following results were obtained, as shown in the box. And given that your gas constant, which is denoted by R, is 8.314 joules per mole dot Kelvin. The first part of the question asks us to state the Arrhenius law and explain the significance of the Arrhenius parameters. Example, activation energy and the frequency factor. So here's the answer for the question. Part A. This is basically your Arrhenius law, which is known as your Arrhenius equation. This your reaction rate constant will be equivalent to your frequency factor denoted by K0 multiplied by Euler's constant to the power of negative activation energy over gas constant multiplied by temperature in Kelvin. I must stress that temperature in this case is in Kelvin. And in the Arrhenius law, we have to assume that your frequency factor and your activation energy are constants. So the only variable we have in the equation would be temperature. And the activation energy basically is the energy barrier needed to be overcome by the reactants before reaction can commence. Frequency factor, on the other hand, is the number of collision between molecules. So part B suggests an appropriate graphical method that can be used to determine Arrhenius parameters. So with a little A math, we will solve it. This is the O equation. We will first start by lawning the entire equation, and when you lawn and Euler's constant, the power will be brought down as shown, and you will rearrange the equation so that it resembles y equals to mx plus c, where m, which is your gradient in this case, equals to negative activation energy over gas constant. Your y-intercept, which is your c, equals to your ln frequency factor. The y-axis will be ln reaction rate constant, and the x-axis will be denoted by 1 over temperature. Part C. Hence, determine the Arrhenius parameters using your answer in B. So in an exam, you will plot a graph using graph paper and work out the equation, and voila, you get your gradient and your y-intercept. But in this case, for better illustration, I am using Excel. So this is your y-axis, which is denoted by ln K. Your x-axis denoted by 1 over temperature. And when you got your graph out, you'll probably get your gradient and your y-intercept. I must stress again, temperature is always in Kelvin. So, using some simple mathematics, you will be able to determine your Arrhenius parameters as shown. So your activation energy will be as stated. Your frequency factor will be as stated. So use your result and C to predict the reaction rate constant at 200 degrees. Briefly discuss the validity of your answers. So you just sub in the answer found in part C, and you probably get your reaction rate constant. This is not true as, the answer is not true as, in theory, we assume that activation energy and frequency factors are constants, but in reality, with the increase of temperature, you will see a rise in your frequency factor, while your activation energy, on the other hand, will be either an increase or a decrease. and they are both not constant. So for part E, with the aid of an appropriate diagram, briefly discuss how the rate of reaction can be increased using a catalyst without increasing the reaction temperature. So assuming constant temperature, we can see the line with the catalyst reaches maximum conversion faster than the line without the catalyst with time. So we've come to the end of our video. I hope you enjoyed, and as to reward you for watching the entire video, I will now release you a pickup line that will get you girls. So it goes like this: hey babe, you're the temperature to my Arrhenius equation. Thank you for your time, and put your comments below, and hope you enjoyed. Bye.